Alright, I'm starting the recording. Okay, let's all work through some problems that Nuda has written for Specialist IA2 practice. So I have not seen these problems besides a quick glance, so I am currently raw dogging them. Will we get practice time? Yeah, everyone, like, if everyone wants, we can get practice time for each question. I give you like a few minutes to try and figure it out, what to do. Probably like 5 minutes max for each question. So does everyone want practice time for the first question? Yes, Lloyd, this is gonna be recorded. Okay. Okay, I'm gonna see if I can screenshot it and then send it, paste it in the chat. And I'm not able to pin it. Check-ins, if your audio's gone, try rejoining the masterclass. That's worked for a lot of people. Yeah, no worries. Yeah, we're doing question one. I'm talking right now, Jeff. If you still can't hear, just try rejoining again, and if that doesn't work, I'll try rejoining the VC. Arctic Wolf, you're glad you're not doing spec? Well, you're in the masterclass, so, do the questions, bud. Alright, when it hits 6:41, that's when I'll start going through the problem. Han, is your IA2 soon though? Cause if it is, then like your teachers like majorly let you down. Oh, okay. In that case, then that's no worries. Like you'll hopefully like be taught the theory by the time you get to the IA2. Alright, it's 6:41. I will start going through the question now. Alright, so question 1 for the lines and planes. So let's look at what we've got. So we have 2 planes given to us. We have 2 lines given to us. And we need to find the intersection between plane 1 and 2. So, does anyone know how to do that? Add them, equate them. Convert into vector form. Yeah, Gaussian elimination. Yeah, yellow, you're right. So we just set them up like simultaneous equations and just solve them, because the simultaneous equation, when they're in the form like when you have 3 equations, that's when we're solving that, we'll find the x, y, and z when all of them are equal at that coordinate system. So that's how we find the intersection where all the planes share a point. But we only have 2 planes, so either the planes will intersect along a line or they won't intersect at all. So let's start with our simultaneous equations. We have 2x minus y plus z equals 5. We have x plus 2y minus z equals 4. We can either solve this using normal simultaneous equations like substitution and elimination, or we can do Gaussian elimination. And Gaussian elimination is just another way of representing the elimination method of solving simultaneous equations. So let's do that. So what we do, we take the coefficients of the x, y, and z. So we have 2x minus y plus z. So it's 2, -1, and 1. And we have the straight line to represent the equal sign on the other side of the equation. So, and we just put in the constant value that we have there. So we'll do that for the second equation. Same thing. 1, +2, -1. And we have 4. Now, when you're doing Gaussian elimination, you want to be solving, you want to be making one of these coefficients equal to each other, but with negative opposite signs, so that when you add them, they'll cancel out and equal 0. So if you see here, we already have 1 and -1. So we have 1 on the first equation and -1 on the second equation. So when we add them, they'll cancel out and equal 0. So let's write what we're doing on the side to better communicate our working out to the marker and also to ourselves. So we have row 2 plus row 1, and we're going to be doing this operation to row 1. So we're adding row 2 to row 1. So we have 1 plus 2, which is 3, -1 plus 2, which is +1, 1 plus -1, which is 0, 5 plus 4, which is 9, and row 2 stays the same. Now, once we have what we want is we want to single out a term on this side of the table. So we want to have zeros and just only 1 in the left side, and because that will mean that we only have 1 variable in the equation, and that will be equal to some constant. But because we're using only 2 equations, it's going to be slightly different. we can't really make one variable equal to anything because we don't have enough like space to work it out, because we only have two equations when normally we need three to get the form 001 or 100 or 010. So what we do is we just take the first equation and we represent it normally, so 3x plus y equals 9. And what we do is we just let one variable equal a parameter. So let's say we let y equal t. So 3x plus t equals 9. And then we solve for t. So we solve for x, so 9 minus t, and x is equal to 9 minus t over 3. Then what we do is we substitute that back into the other equation to find the other solutions for the other variables. So we have 1x plus 2y minus z equals 4 for the second equation. So we substitute in x, we substitute in y, which is equal to t, because we let y equals t, and we're solving for z. So z would be equal to 9 minus t over 3 plus 2t minus 4. And we'll expand this out, which gives us 9 minus t plus 6t minus 12. So z is equal to negative 3 plus 5t. So we have all of our variables. We have the solutions to all of our variables in our system equations. How do I get rid of the over 3? You just times everything by 3 over times everything by 3. Oh no, you're right. Sorry. There should still be an over 3. Yeah, so what you do is you times everything by 3 over 3, because that won't change anything since that's equal to 1. So this is equal to 3 over 3. So it would be over 3, and then you just multiply the 2 and the 4 by 3. So they go to 6, and then it goes to 12. So now we'll have what we had before. So negative 3 plus 5t all over 3. Yeah, I'm reading chat, yeah. So now we have everything in terms of t, and we have it in terms of t because we don't have enough information to solve for one single point of intersection, because there's only 2 equations, and we need 3 to have 3 unique solutions. So we just say they intersect at these coordinates. So x equals 9 minus t over 3, y equals t, and z equals negative 3 plus 5t over 3. Or couldn't we have just let z equals t from the beginning? Yeah, we could have. You're right. This is the first time I'm doing these questions, so these might not be the most efficient solutions, but you can use a bunch of different alternative methods to get to the same answer. Why make yt? Because the y was just like the simplest variable to do in this equation. So y only had a coefficient of 1. So it made sense to make y equal t since it was simple. You could make z equals t like Chegan said. So we have these equations, these coordinates, but we can also represent it in the form of a vector line. So if we have x, if we rearrange to find t, Or if we just rearrange to find it in terms of x, y, z as a vector, we will get our line equals, we have 9, we have 0, and -3. Sorry, we have 9 over 3, 0, and -3 over 3, plus t, minus 1, 1, 5 over 3. So minus 1 over 3. And what this is doing is we're just taking the constant term of each of our coordinates. So the x part, the constant term is 9 over 3, so we have 9 over 3 in the x component part of the vector, or the I component of the vector. RT equals, yeah, that's right. It should be a -1 over 3, shouldn't it? For the x component of the direction. Yeah, so it's 3, 0, -1 plus t, -1 over 3, 1, 5 over 3. And that's our two possible ways we can represent the solution. We can either represent it as just the coordinates themselves, or a vector equation of a line. And that's because when we have the two planes intersecting, they'll intersect. If they do intersect, they'll intersect along a line. It's like if you had like two sheets of paper and you face them through each other, they're not gonna face through at a point unless you like cut it, like touch it like really like a point to the other plane. But because the planes are infinite, there's no end point, right? And because there's no endpoint, we only have a single line where they intersect. And that's the equation of the line. Yeah, Arctic Wolf, is it making sense? Now for B, we want to find whether L lies in, intersects, or is parallel to the plane pi 1. And we have to justify our answer. So we have three possible options. We have either L lies in the plane, we have it either intersects the plane, or we have that it's parallel to the plane. Now, there's multiple different ways of checking each option, but that's time consuming. You don't want to be doing three different equations at a time. So I believe there is a way to do this very efficiently. If we substitute our okay. Yeah, okay. So what we have is it either lies in the plane, or it either intersects, lies in, or is parallel to the plane. So these two options are mutually exclusive. And so is the third option, but specifically, Chagins, do we need to represent the plane in vector form? Easy enough, see if it fits in right. The plane in its current form is basically the same as vector form. And representing the plane in vector form won't necessarily make it easier to see if the line fits in it. But anyways, L lying in the plane is means that okay, the L is L, the line, is in terms of lambda. So lambda is the parameter for where in the line the point is if we are trying to find the point of a line. So say we're starting from here. If we're up here, there's that much lambda that we have multiplied the direction by. So if we have that the line lies in the plane, so the first option is if it lies in the plane, that means that there's an infinite amount of solutions where the line will have intersections with the plane. So there's an infinite amount of solutions, so there will be an infinite number of lambdas that will fit the equation, that will satisfy the condition of the line intersecting the plane. If it intersects the plane, then lambda will only have one solution. And if it's parallel, lambda will have no solutions because it doesn't intersect the plane at all. So what we do is we just substitute the components of L into the equation for the plane. So let's go over and do that. We'll do it here. So L had an equation R equals 1, negative 1, 2 plus lambda 2, 1, negative 2. So that means x equals 1 plus 2 lambda, y equals negative 1 plus lambda, and z equals 2 minus 2 lambda. When we convert the equation of the plane into Cartesian form, right? We have it in terms of x, y, z. And then we can substitute these into the equation for plane 1. So plane 1 equals, we had it equals 2x minus y plus z equals 5. And that's the equation for plane 1. So what we do is we just put the x values in the x spot, the y in the y spot, and the z in the z spot. And what we get is 2 times 1 plus 2 lambda minus minus negative 1 plus lambda, which is y, plus 2 minus 2 lambda, which is z, and that is equal to 5. So when expanding this out, and then we can add our like terms and our constants. So we have 4 lambda, negative 1 lambda, negative 2 lambda, that is equal to 1 lambda. 2 plus 1 plus 2, so plus 5, and that equals 5. So lambda is equal to 0. That doesn't mean that lambda has no solutions. 0 is a solution. So we have one solution for lambda. So that means that the line is in the area of the plane exactly once. So it intersects the plane. intersects 1's right at 1, -1, 2. Yeah, it does. Yeah, and yeah, we can find that those coordinates by plugging in 0 for lambda. So r0 equals 1, -1, 2 plus 0 times the direction vector, and that is just equal to 1, -1, 2, which is what Cheggins said. So that's how we see if the line intersects, it lies in, or is parallel to the plane. Now, being parallel to the plane, quick side note, parallel to the plane means you can lie in the plane. But because we already have that the line lies in the plane already, that means that if the line is parallel to the plane, it means it is completely outside of the plane. And because it's parallel to the plane, it doesn't go towards the direction of the plane because it goes towards infinity. So it doesn't go towards the plane and it never touches it. And it doesn't lie in the plane because that's already ruled out here. Does anyone have any questions with these two problems? If they were instead parallel to the plane or lie in it, that would imply that those were the only options that the line could take. So that would mean that there would either be infinite solutions for lambda or no solutions for lambda. Yeah, the equation would be different in some way. But if the equation was the same, so like, yeah, if the line was to be parallel to the plane, what would it look like that we can't solve for lambda? So, it would look like something like this. Okay. My laptop's low-key bugging out, but so example of no solutions. We would have something like, once we sub in x, y, z, we would have something like x plus a lambda. X plus a lambda plus y plus b lambda plus z plus c lambda equals d, such that the lambdas added together will cancel out and equal 0. So there will be no lambda in the actual equation. Yeah. But you would have to check if the starting point of the line was in the plane or not, because if it was, then it would mean it lies in it, and if it's not, then it would mean it is parallel to it. So this doesn't actually tell us which of the options it actually is. This just means that it is either it's parallel to the plane, but that could mean it either lies in the plane or it's outside of the plane completely. So you have to sub in the initial coordinates of the vector line. Yeah, no worries, chickens. Han, what is lambda? Lambda's just a parameter. It's like t or mu. Like, it's just a variable we say that to, like, express the infinite length of a line. So, a line in vector space is defined as... So we have a starting point. And right, so the general form of a line is like R A B C equals plus let's go lambda D E F, right? So let's say that this is origin. The position vector of the starting point will be ABC. And the direction vector of the line, so let's say it's going this way, that direction vector, when we have it from the origin, that is DEF. And the lambda just means that it's infinite. Like we could have any direction, any amount of magnitude of DEF. Right? Does that make sense? Yeah. Okay. Cool. Any secret strat to learn everything? Do practice questions and especially with vectors, be able to visualize it in 3D. Like you can use Desmos and like YouTube videos to help with that. Let's move on to the third question. We need the angle between L and M. Now this should be pretty the formula we need to use should be pretty obvious for most specialist people. So does anyone know what it is? So we're looking for the angle between lines. Yep, dot product. So we'll use dot product for the angle. So we have L dot M equals magnitude of L, magnitude of M, cos theta. Now, our equation for L is -1, -1, 2 plus lambda, and it was 2, 1, -2. And M, the equation for M is 3, 0, -1 plus mu 1, -2, 2. Okay, so we've got a bit of a problem here because we've got two vectors in each of the lines. Like, we've got two vector components in each of the line equations. So, is that mu sign the same concept? Yeah, exact same concept. It doesn't matter like what variable we use, as long as it's like multiplying the direction vector, it's the same concept. But we have two vectors in each of the equation in our lines. Does anyone know what vector we use to compute the dot product? Yeah, chickens, that's exactly right. Geez, you're locked in. So we will use only the direction part to compute the dot product. So we will have 2, 1, -2 dot 1, -2, 2 is equal to the magnitude. So we have 4 plus 1 plus 4 times 1 plus 4, and these are the same. Okay, so with our dot product, remember we just multiply each of the corresponding components and then just add them together. So 2 times 1 plus 1 times -2 plus -2 times 2, which is equal to square root 9 cos theta. So we have 2 minus 2 minus 4, which is 3 times 3 cos theta. So we have -4 equals 9 cos theta, -4 over 9 cos theta. Theta equals cos inverse -4 over 9, and okay, 116.39, okay, and theta equals 116.39 degrees, or 2.031 radians. But notice how this is an obtuse angle. Yeah, when we have the angle between vectors, there's going to be two angles, right? There's going to be the small one and the big one. Because this is an obtuse angle, we need to find the smaller angle, so we need to subtract it from 180, right? Because it's a supplementary angle, because it's a straight line. So we have our theta. Now we need to find alpha. So alpha equals 180 minus 116.39, or pi minus 2.031. And that equals, can someone do the calculations, or around 63.61. Oh, damn. Or I'm just plugging it into my calculator. Did everyone get that if they did it in their calculators? Now, this is an important note to make. When we find the angle, we need to find the acute angle, because there's always going to be an obtuse angle and an acute angle, and the acute angle is the one that's the easiest to work with, because big numbers are scary for mathematicians, so they prefer small numbers. Yeah, they prefer the Q one. Alright, that is lines and planes done. Now on to sphere geometry. But wait, quickly before I move on, does anyone have any questions? Lloyd, if it's a line and plane, 90 minus theta. If it's a vector times 2 or a plane, it's 180 minus theta. Wouldn't it be the same in both cases? Because the plane would be essentially the same as a line. It would go on both sides, and then the line between it would have one angle and then the other angle. You might be misremembering something, because I also remember something it being 90 minus theta, but I don't think it checks out because of it's the same as the line and line. Oh, I think you're thinking of the normals of the plane, like the angles between the plane. You find the normals of their line, or the angle between the normals. So say this is a plane and another plane. The normal, and there is another normal. The angle between those will be 90 minus the actual angle of the planes between each other. So, and we can work that out based on this. So since they're straight lines, the angles behind each other across the opposite of the lines will be the same. And because these are 90 degrees, then that means this angle here, so let's call that theta and that alpha. That means we have 360 is equal to 90 plus 90 plus theta plus alpha. So that means we have 180 equals theta plus alpha. So 180 is equal to 180 minus theta is alpha. Okay, never mind then. Does anyone have any questions about that? Angle between planes equals angle between normals. I think that checks out. But based on the diagram, it seems to be the same unless I'm missing something. Red and blue lines are the normals, so yeah, they're the normals. I don't think I'm missing anything from this. So the angle between planes is just 180 minus the angle between the normals, I believe. Line of plane. Oh, angle between the line and the normal to the plane. Oh, yeah. That makes sense. Yeah, cause you don't know the actual like orientation of the plane. You have to base it off the normal. Okay, yeah. Yeah, so that's line, plane, plane, and the line with the plane is we have a line, and then we have the normal. And the angle between those will give us the angle between the, sorry, it won't give us the angle because you have to subtract 90 because that's a big old right angle. So 90 equals, we'll do theta and alpha again. Equals theta plus alpha so alpha is 90 minus theta. I'll just color code the other one up top. Yeah, does that make sense to everyone? Alright, cool. Cool, let's go to question 2. Okay, does everyone want working time? Do people want working time? Alright, cool. I'll give everyone 5 minutes of working time. Yep. Okay, now I'm gonna tidy up the everything on the screen. Alright, is that enough working time for everyone? Alright, cool. Let's start with question 2. Alright, so we're given a sphere, a line, and a plane. So we need to find the values of r, which is the radius of the sphere, for which the line is tangential to the sphere. And what that tangential means is that it not only touches the sphere, but it's at 90 degrees to the radius. Yeah, it intersects once. So what we have to find is that we have to find one intersection, and 2 the radius being at right angles to the radius. Yeah, Cheggins, I think you're right. Yeah, I think, yeah, it does. Yeah, you're right. But it's still true. Like, it has to be at right angles to the radius. That's what tangential means. But we only have to find one intersection because it's the other part it guarantees the right angles. So let's find the one intersection. So we have the center with 2, -1, 3. So we have the equation of the sphere. And we have the straight line. Now, this is tricky because we have 2 unknowns, right? We have the r and then we have the t. So it makes it tricky to find the values of 1 when we only have 2 unknowns. Do we need to convert the line into Cartesian, maybe? Yeah, but if we convert the line into Cartesian, we'll still have x, y, z, or they're all in terms of t. What we have to do is we have to find the values of r for which the line is tangential to the sphere. So, and we're given that r is greater than 0, so that likely implies it's related to a square root of some kind, and that we have to eliminate the negative option from the positive the negative option from the plus minus. Let's think about it. Let's think about let's think about the question in terms of 3D space. Dot product with P minus C and D, where P is intersects. Yeah, if we get the line into that Cartesian form, then but that's all that's equating t's, right? We'll still have x equals something t, y equals something t, z equals something t. So what we're really trying to find is that we're like sort of inflating the sphere. Like r could be anything. So we're starting with really small sphere, inflating it until it touches the line only once. So we want distance from that point to the line. Yeah, that will give us r. Yeah. When we're in this sort of situation, it's actually sort of much easier because we can just work on finding the distance from the sphere to the line. So let's call that d, and r will be equal to d when it only touches once. So what we're really just trying to find is distance of a point from a line. And when we're trying to find the distance of a point from a line, we are going to be using the scalar resolute, and it's related to vector projection. So we know the coordinates of the line. So we know the center is equal to, let's say, OC, where C is the center. OC is equal to 2, -1, 3. So in our sort of diagram, we have 2, -1, 3. And we just pick random point on the line. So let's just pick when t is 0, so r 0. So that would be 6, 1, -1 plus 0, -2, 1, 2. So r0 will be just 6, 1, -1. And let's say that is over here. Now, what we need to find is the vector from R to the center. So what we're finding is from from R0 to OC. And what this will be equal to is OC minus R0. So we have 2, -1, 3 minus 6, 1, -1, which is -4, -2, and 4. Where is R0 on the OG diagram? T equals 2/3. Yeah, you can definitely do t equals 2/3. You can pick any random point on the line. Like, I'm gonna show you that it doesn't matter what point you pick, because the point that you pick, wherever point you pick. So let's call this this will be the hypotenuse. So let's call that h. This diagram will turn into this sort of diagram. So we have the center, we have h, and if we project h onto the direction of the line, I'm going to use a different color. Projection of h onto line, then that will give us a right-sided triangle. Do you all agree with that? So we have that distance being d, which is what we're trying to find. So we have h squared equals d squared plus projection squared. Now it doesn't matter what point you choose, because the projection will change accordingly. Does that make sense to everyone? So what with our numbers that we have h equals -4, -2, 4. OC isn't a point on the line. OC is the position vector of the center from the origin. So from the origin, we go from the origin to the center, and that's where the center is. That's where the circle is. And let's say that the line is here. So what we're doing is the circle inflates up to here, and we're trying to find the radius or the distance. So we are finding the distance, the vector from a point on the line, any point on the line, to the center. Does that make sense, Yellow? Yeah. So what we have h, now we need to project h onto the line. So projection of h onto the line is equal to h dot line, and we're using the line's direction for this, remember, and that's divided by the magnitude of the line direction. So we have -4, -2 for dot, and the direction of the line is -2, 1, 2. And we divide by the magnitude of -2, 1, 2, which is 2 squared plus 1 plus 2 squared. So working that out, you have +8 minus 2 plus 8 over 9. So we have 16 minus 2. Sorry, that should be a 2 over 3. We have 14 over 3. So that's the distance of the, that is the distance of the projection of the line. That's the magnitude. So this should be magnitude. So the magnitude is 14 over 3. So we have half of our h squared equals d squared plus proj squared. You're doing this stuff quite different. Yeah, there's a bunch of methods to be able to do this. This one, I think this is the most efficient way. But let me know what your other method was, if you remember it. So we're gonna go find the magnitude of h. So h equals 4 squared plus 2 squared plus 4 squared equals 16 plus 4 plus 16, which is 32 plus 4, which is 36, which is 6. So we have 6 squared equals d squared plus 14 on 3 squared. We have 36 equals d squared plus 14 squared over 9 and equals 36 minus 14 squared over 9. D squared equals, so what does d equal? D equals 8 root 2 on 3 units. So the radius will equal 8 root 2 on 3. Radius will equal that as well. Right, does that make sense to everyone? That's how you got the solution. What is the method you were doing? Oh, you are finding t, the point where it's directly like perpendicular to the center, and then you find the distance from there. Oh, okay, yeah. Okay, yeah, that one, yeah, I think that might be a bit more efficient, but it's pretty much the same. So what we were doing is we had center and we need to find A. So the direction would be, so we have the direction dot product AC would be 0. So we know the direction, that is -2, 1, 2, dot product AC. So we don't know A, but we know C, so we know AC is equal to, if we go from A2C, that is a negative A plus C, that is equals 0. Negative 2, 1, 2, dot product. So we have the negative of A, which is a random point on the line in terms of t. So we have 6 minus 2t, 1 plus t, negative 1 plus 2t, plus c, which was, I believe, 2, negative 1, 3. And that equals 0. So negative 2, 0, 2, dot product, negative 6 plus 2 plus 2t, negative 1 minus t, 1 plus 3 minus 2t, equals 0, negative 2, 0, 2, dot, negative 4 plus 2t, negative 2 minus t, 4 minus 2t, 0. So we have 8 minus 4t plus 0 plus 8 minus 4t equals 0. Okay, we've gone into a bit of trouble. Why did it change to negative 2, 0, 2? Oh, yeah, I misread that. Okay. Thank you for picking up on my mistake. So we have an extra negative 2 minus t. So these cancel out, but we have t equals 2. So now we just know that, so we know that AC is equal to negative 6 minus 2 times 2, 1 plus 2, negative 1 plus 2 times 2, plus 2, negative 1, 3. And this will equal negative 6 minus 4, 3, negative 1 plus 4, which is 3. So that's negative 1 plus 4, plus 2, negative 1, 3. And that is negative 2, negative 3, negative 3, plus 2, negative 1, 3, which is 0, negative 4, 0. Okay, and then the magnitude of AC was 4, which is, yeah, okay, yeah, that's what I'm confused about as well. Eight minus 4t in the other one. Oh my god. Oh my days, okay. The audio keeps cutting out. Okay, I'm not too sure why that is. Okay, sorry about that, everyone. That's my mistake. So we have 16 minus 8t minus 2 minus t, which is 0. 14 minus 9t equals 0. And then we have t equals 14 over 9. No, negative 14 over 9. And that is, yeah, that all checks out. No, positive 14 over 9. Which is, oh yeah. Cool. And then that means AC equals, oh god, that's a lot of calculations we have to do. Negative 6 minus 2, 14 over 9, which is very ugly. And that is adding to 2, -1, 3. So AC is equal to negative, I'm using my calculator, I can't be bothered doing this. Negative 26/9. 23/9. And 14/3. Plus 2, -1, 3. And when we add that all together, we get... Okay, we get AC equals -8/9. -32/9. And -5/3. So the magnitude of AC will be all of those squared, and we add them up, plus which is not the same as the other. Is it? Okay. Okay, is there a mistake in the numbers? Yeah, there must have been an algebra, like an arithmetic mistake. Okay. That's not supposed to happen. Oh my god. Answer. Okay. Oh, I think I see where it is. Yeah, the calculator error. So then the bottom one should be bottom one should be 8/9. And the answer will be 8√2 Okay, we got there in the end. I really do not like that method. You can see the comparison, the working out needed versus this. I mean, it just depends on which one you like more. If you like subbing in numbers and then doing a lot of calculations, you can do that. Yeah, it's probably simpler on the surface, like conceptually, but it's just the amount of arithmetic you have to do. And like, even if you have a calculator, that's a lot of like manual labor. So let's finally move on. The minimum distance between the sphere and the plane in terms of r. Now this is another point, distance between point and plane one. So the question wants the answer in terms of r though. So let's start doing the algebra and see how it goes. So we are once again finding point and then plane. So point and plane, and then distance between the two. So we have the center, and then we have the plane, which I believe was pi 1. No, it's not given. Okay, so it was 2x plus y, I guess. I think minus y plus 2z equals 14. And the center was 2, negative 1, 3. Yep. So we need to find the minimum distance between the sphere and the plane, we just need the distance between the sphere and the plane, and to get it in terms of r, because the radius can be whatever. It can be like that, or it can be that. The distance we find to be from the plane, from the point to the plane, is gonna be the radius minus the distance, and that's the minimum distance from the sphere to the plane. So the actual distance, so we're finding d, but the actual distance of the sphere will be d minus r. So let's start by finding d first. So to do the distance from a point on the plane, distance from plane to a point, we need to find, now keep in mind this might be different from everyone else's method, but what I do is I find a random point on the actual plane itself. So I have x, y, z on the plane, and once again I take the xyz and I find the distance from xyz, the vector from xyz to the center. So let's call the point P equals xyz. Find PC. So we have C minus P, because we're going back from P to the origin all the way back to C. We have 2, negative 1, 3 minus x, y, z. And that is 2 minus x, negative 1 minus y, 3 minus z. Now, what we have here is similar to what we had in the previous example. We had a vector from the plane to there, and what we have to do is find the scalar resolute of that in terms of the normal, but because the normal is already perpendicular to the plane, Chegans, I'm speaking right now. Because the normal is already perpendicular to the plane, we don't have to do any Pythag to actually get the distance. So we just need to do PC dot normal, and with the unit normal, or we can just go normal over magnitude of normal, and that will give us the distance. The distance is then equal to 2 minus x, negative 1 minus y, 3 minus z, dot product 2, negative 1, 2. And then divided by 2 squared plus 1 plus 2 squared, and we've seen time and time again that is equal to 3 because it's root 9. So on the top we have 2, so we have 2 times 2 minus x. We have negative 1 times negative 1 minus y. We have 2 times 3 minus z over 3. And we have 4 minus 2x plus 1 plus y plus 6 minus 2z all over 3. And that is, I want everyone that's currently watching to look very closely. If I group all the variables together, if I group them as negative 2x plus y plus minus 2z, and I have the rest of the constants here, if I take out a negative, so I'll get negative 2x minus y plus 2z plus 4 plus 1 plus 6, which is just 11. That's all over 3. If we see this expression, we already know what this equals because of the equation of the plane. We had 2x minus y plus 2z equal 14. P is just a random point, yeah. So we have this expression, and that's the same as the one in our equation. So we have 14, and we can just replace it with 14 over 3, and thus we will get negative 3 over 3, which is negative 1, but we'll just take the magnitude equals 1. X and y equals 0 and solve for z, right? No, because x, y, z is a random point, but we're not trying to solve for x, y, z. It just happens that when in our equation x, y, z becomes the normal, the equation of the plane, because we're cross-producting it with the normal. No, we're not solving for x, y, or z. It's just a random point that we use to find to have a vector to project onto the normal. But anyway, we have a distance of 1, so the distance equals 1. Therefore, the distance from the sphere to the plane, in terms of r, equals 1 minus r. Does that make sense to everyone? Alright, yeah, that's all good, check-ins. Okay, I'm gonna give the screenshot the third question and let everyone have a chance to look at that while I rearrange the working out a bit neatly. Actually, I'll just go. D is the way we solve for D. We found it as negative 1, but because it's a distance, we just take the magnitude of it. Yeah. There should be a big magnitude thing here. So yeah, nice catch, Oz Natures. Yeah, it also works if you get a random point using the equation, but it's essentially the same thing because we use the equation to substitute x, y, z. All right, is everyone done with question 3, or do they want me to go through it? More time? Okay. Do we want to call it a night after question 3? Cause Nuda, I assume Nuda is also willing to go over the other questions. Yeah, that's fair. That's fair. And it also gives you more time to actually do the other questions yourself. If Cheggins is done, I'm done. Yeah, real. Alright, I'll give everyone 2 more minutes. Alright, Cheggins, do you want more time or? Alright, I think I'll start with the question now. Yep, all good. Okay. So, we're given a system of 3 equations, and so first off, it's to write the augmented matrix for the system and reduce it to row echelon form, which is basically to just put it into Gaussian elimination and eliminate it into the 0, 0, 1, and in a specific format. So row echelon form, that is the 1, 0, 0, 0, 1, 0, 0, 1, and it's equal to A, B, C. I'm just gonna quickly check that that's correct, because these terms are confusing because they are very, very similar. Yeah. Yeah. Only bottom left zeros. Yep. Okay. So it's just asking us to basically solve for it. So that's pretty simple to do. At least relatively speaking in the other parts of the question, which look a bit cooked. So we have x plus y plus z. Sorry. We have the coefficients of it are 1, 1, 1, 2, 2a, 2, which is equal to b, 1a, 0, which is equal to 1. Alright, so now we need to just solve for it in row echelon form. We need to get these parts into zeros, which is easier said than done, but it seems like the question is designed for it, because if you notice, these are very similar. So if we subtract row 3, if we subtract row 2, subtract row 3, and we do that to row 2, we will get 1, 1, 1, 2, 1, 0, 2b minus 1, 1a, 0. So we have that 0. And from here, if we do okay, this is interesting. Oh no, I got it. Okay. A good way to good rule of thumb is to get a 2 by 2 and get zeros on the same column. Is it illegal to go R2 3? It isn't illegal, but if it's just very confusing for the marker and for yourself. So if you're confident you can do it, then go for it, but personally I wouldn't. But if we go row 2 minus 2r1, and we go that row 2, that's the new row 2, 1, 1, 1, 2. So we have 0, a, 0, and we have 1a, 0, and we have 2, we have b minus 2, so we have 1, because then the a's dip as in like go away. Oh, you're right. No, I think there might be some problems, because if you subtract this from there, then because that a is gone, then there's nothing to subtract that a with. So it's like you're getting 2 a's to subtract with from nowhere. Does that make sense? Yeah, audience, it started. Yeah, stay with us. But right here we have, if you notice, we just have that a, and we can get that into the row echelon form we need if we just divide by a. So if we go 1 over a row 2, and that is the new row 2. So we can also do we can have row 3 subtract 1 over a row 2, which is the new row 3. So 1 over a will turn that from a into 1. So we will get 1, 1, 1, 2, 0, 8, 0, 1, sorry. b minus 2 over a, and we will get row 3 minus, okay, no. How I got a and b minus 2 from row 1 minus 2. No, it's row 2 minus 2 row 1. It would be a minus 2. Yeah, you're right. And it should be b minus 4. Yeah, you're right. Okay. Okay. Yeah, okay. So first let's just subtract. We need to find a way to make this turn into 0. So a turn into 0 purely from a minus 2. Or we can just have a subtract a minus 2, which will give us 2. And we can, as long as we get rid of the a's, we can use any other rows to do that. So let's have, so first off we'll have 1 over a minus 2 row 2. But before we do that, we'll have row 3 subtract row 2. So we use the a minus 2. We use that to cancel that out, and then we cancel that out by dividing by a minus 2. So 1, 1, 1, 2. We have 0, 1, 0, b minus 4 over a minus 2. So we have 1, positive 2, 0, 1 minus b plus 4. We're allowed to divide by a minus 2, because, yeah. So if you see here, we have 1, and we can just use that to subtract the 2. It's going to be really cooked for the right hand side, but we can, as long as we get row echelon form. So we have 2 row 3 minus 2 row 2, and we'll subtract row 2 from row 1 while we're at it. So it's 1, 0, 1, 2 minus this ungodly abomination of a fraction, 0, 1, 0, minus 4 of a minus 2, and then we'll have 1, 0, 0, 1 minus b plus 4 minus 2, b minus 4, okay. But we're very close to row echelon form, we just need to subtract this from that. So we have row 1 minus row 3. To row 1, we have 0, 0, 1. 2 minus b minus 4 over a minus 2 minus 1 minus plus 4. Minus b minus 4 over a minus 2, and we need to simplify that eventually. Okay, we have 0, 1, 0, 1, 0, 0. We have row echelon form. It's not like that part with zeros, but if we just like flip it around, but if we just reorder it, then we will have it, and I'm just going to leave it in here and simplify. So 0, 0, 1, 0, 1, 0, 1, 0, 0, and it's gonna be 1 plus b minus 4 plus b minus 4 and we have 1 minus b plus 4 minus 2. And we need, okay, that the ink didn't register. Okay, OneNote's playing up. Check-ins, would you post in the chat you had the new row 3 equals that. That is way more cooked than what we have. So that's part A done. And we need to find when it has a unique solution. So that means our row echelon form, the A, B, C, there needs to be a real number. So A, B, C, it's a real number. Okay. Conditions on. Yeah. We just need to have, for a real solution, we need to have one row being 0, A, 0, B, and the real numbers. Yeah, you're right. Yep. If we have, what we can't have is 0, 0, 0, 0 or 0, 0, 0, A, because that's, yeah, you got that right. Yeah, exactly. So we need to somehow find A and B so that there's a real solution. So let's start with our initial matrix. Actually, oh geez. For part B, it's literally any B and any A, but A 1 plus 2. Where A can't equal 2. Yeah, you're right. Yeah, so the A can't equal 2 because, so we have B minus 4, we have 0, 1, 0, B minus 4 over A minus 2. A minus 2 can't equal 0, so A can't equal 2. And this checks out because in our original thing, we had 2A2, 1, 1, 1. If A was 2, then 1, 1, 1 and 2, 2, 2. would cancel out. So we would have 0, 0, 0. We would have 1, 1, 1. And b minus 4. So we have no solutions. Yeah, check-ins, you're cooking, You're right. So A has to equal 2. B doesn't have to be anything, so B is real, A is real, but not 2. So A just can't equal 2 for a real solution. Let's move on to the other one. Infinitely many solutions, so infinite. We'll take our example from here. So when A is equal to 2, we have 0, 0, 0 is equal to B minus 4. So we need B equals 4 for a case where we have 0, 0, 0, 0, which is infinite. Thus A is 2 and B is 4. Or B minus 4 over A minus 2 equals Y with our 0, 1, 0 minus 2. With that, if B equals 4, A is equal to 2, 0 over 0. So it's it isn't like infinity, but it's indeterminate. Yeah, so that checks out. But this isn't actually that great of a like way of proving that it's like infinite solutions. Use ignore this. Use this. Just use this, because indeterminate doesn't really mean too much. But that was just random train of thought. So now we have part D. With that matrix given, it's yeah. Oh, okay. Okay, I see. So you're saying that the row echelon form, you could have gotten it just from these three being 0. So we could have gotten if we had had that being 1 and that being 0, then we could have gotten it. Okay, yeah, I see what you mean. So this is overcomplicated. Now for no solutions, it's pretty much the same thing, except A equals 2, B just isn't 4. So we will have 0, 0, 0, and then B minus 4. I got 99.85 eta. 99.85. Did I say that? Yeah. Okay, So that's 3D, and then 3E. Okay, this should be chill. This should be chill. So with one solution, we have everything like intersecting at the same place. So then we have like maybe a diagonal one. So wait, so it's bad drawing. So maybe there's one like that. So if we can see that they're all kind of like just that one place. And then infinite is a line. And then all of the planes are on that line. That's the line that they're on. And then no solution is they're all apart from each other. So they're all parallel. So that's question 3 done. Just yeah, no worries, chickens. Alright, does anyone have any questions? Any other questions, like with any of the questions? Any like any confusions or Nuda, I imagine Nuda will finish the rest of these questions off. But in the meantime, you should use the time off to take a look at the last couple of questions. And Nuda also had an extra complex numbers question. If anyone wanted that, I can copy paste that in the chat. Okay. Yeah, no worries, guys. Yeah, so there's question 4 and 5 left, and that complex numbers question sheet, that will be like another like collection of questions. So I did 3 questions tonight. He'll probably do 3 questions the other night. No problems. Yeah, the complex numbers look pretty cooked. Peace out, peace out. Okay, I'm gonna end the recording here.